So for any beam or structure that has with a given cross section that's uniform across the length, um, there will exist a system, an axis system called the principal axis, where the mixed moment of inertia will be equal to zero. So our two principal axes we'll define using instead of using x and y, we're going to use the letters m and n. Okay, so for these principal axes, uh, they'll have a specific moment about the axis, or a bending moment. So we'll denote that with a capital M, with a lowercase m for the bending moment about the m axis, and a capital M and a lowercase n for the bending moment about the n axis. And for each of the axes, m and n will also have a second moment of area, or a moment of inertia, which we'll denote with a capital I m for the moment of inertia about the m axis, and then for the moment of inertia about the n axis, we'll denote with a capital I and a lowercase n. So the stress in the x and y direction, using these terms above, can be written in the following form, where the stress in the x direction would be equal to the moment about the m axis times the distance from the principal axes to the point of interest, divided by the moment of inertia, Im, minus the moment applied about the n-axis times the distance from the n-axis to the point of interest, m, divided by I n. Okay, so we'll do some examples throughout the text, where we'll kind of draw out each of these variables and explain where they come from, um, in the following videos.